Right.
Megan, it still says is joining. David, I always wondered if your cat was really alive, but it is. I see it move now.
He's got a
Yeah,
stuff.
that's Daisy. You haven't seen her move. Yeah.
No, it's just a lump usually.
Oh, Daisy.
Hey, David,
Yeah.
I think you'd enjoy this helmet. Oh, hold on.
You got to take the background away.
Yeah, that's what I'm doing. Where's the, how do you say no background?
Drop down next to your video, down at the bottom. Do the little arrow. There we go. No. Excuse me. It's really not Corona, I swear. Now, since everybody appears to be here. All right. Welcome, everybody. I'm glad to see that you're all here.
Wow, you're in a different spot.
Me?
Yeah.
No.
Aren't you? No.
I can make it look like I'm in the same spot.
No virtual background.
Oh.
No, he usually has a window behind him, don't you?
No, there you go.
I think one day you did it by a door, and that's why they thought it was different.
Yeah.
Did you sit at like your dining room table or something?
I don't think I ever did it from my laptop, but maybe. I've always done it from this room because this is where my desk computer is.
Gotcha.
So, all right. So, a couple things. Let's go over first. I'm going to log into Blackboard as a student, then I'll share my screen with you.
Oh, I redid that wheel, and now it's good. I
Good.
got like maybe 10 more steps to do, and then it's done. So,
Well, hold that for your next class because that'll be at 10 o'clock.
all right.
All right. So, let me share this guy. Share screen. I'm going to share my whole screen so you can see it. I'm going to shrink that.
Oh, you guys should watch the movie. I think it's called Bloodshot with Vin Diesel. And actually, this has to do with our classes because his body is actually made out of nanites, whatever they're called.
All right.
It's actually a pretty good movie.
Can you all see my screen?
Yes.
All right. So we've got the class here. And content. And I set this new motion set up in configuration. This is where you get the download from. Once you've downloaded it, you can run it. So like if I run new motion, I just type PNEU and it brings it up and I click on it and it runs it. And when it runs it, mine won't complain about the license because I put the code in already, but I'll show you. So now mine's running, okay? I'm gonna do a file open. And I got one called 4-cylinder here. And let me make that big. And I'll do view, zoom in, make it see, come on. So there you can see the complete thing. And if I run simulation now, you can see high pressures in dark blue, low pressures in light blue. I push the push button. You can see the 4 cylinders go out. Once the 4 cylinders goes out, it swaps over. and the 4 cylinders come back. So that's the whole simulation. So that's the problem. But what I wanted to show you was when you go to New Motion and you have New Motion installed down here in this window, or wherever you run New Motion from. So I'm just going to type PNEU. Up here in this window, there's New Motion. If I was to right mouse click on it, I could say Run as Administrator. Or down here in this window, see where it says Run as Administrator? When you run it as an administrator, it asks you this. Now, for some reason on my computer, I'll get a file error every now and then. I have to do that 3 or 4 times. But I say yes.
See that dialog box where it asks you stuff.
Which dialog box? What?
You said it asks you this. I didn't see anything on your
Okay, I'll do it again. So down here in Windows 10, I take PNEU, right? It brings me here. Do you see the New Motion here where my mouse is? Let me annotate. Yeah. Of course, it disappears when I do the annotate. All right. PNEU. All right. Can you see the lower left screen? New Motion. All right. And I had to let Keenan into the room. We're still missing a few, so all right. So here we've got the new. So PNEU. Hopefully, no more interruptions. I've got New Motion up. I can right mouse click, and do you see the dialog box that popped open? Run as administrator or open file location. Okay, I'll show you how to do that too. But here on this right-hand side, it also shows run as administrator or open file location. Gives me the exact same menu. So I'm going to open the file location to show you how to do it the other way. So here's my file screen, right? Here I can also right click and say run as administrator. Any way that you run it as administrator, you need to run it as administrator in order to install that license code, right? You need to run it as administrator to install that license code. So click Run as Administrator. You'll always get this dialog box. Do you want to allow this app to make changes to your device? Yes. And then I'm running it as administrator. And it's checking my license, so it's happy. So there's New Motion running, but it's running as an administrator now. But in this screen, the first time you license it, when you license it, it should come up. All right, I'm going to tell you about a couple problems I had with New Motion. So I can do a file, open, and I can open my 4-cylinder. If I do a file, save as, if you try to change it to be anything but what's in there right now, that directory, like for example, I'm going to go save it on my other directory. So I hit that.
the other day.
Yep. And then I go up again to the C directory, and then I go up to there, and I'm going to come back down and find my Dropbox, right? So there's my users, there's Jeffrey, here's my Dropbox folder, and wait, poof. That's the problem folks have been having. It won't save unless you save it where it wants it to save it. So just save it and copy and paste it.
Actually, there may be another thing you can do. I noticed this with Hydromotion. It might be possible to do the direct. Oh, were you trying to save it using the directory stuff there?
Yes, yes.
On the right-hand side and go through there.
I did that. Tried that too. It turns it off. It's a pain. Just basically what I did was simply save it. Save it in the directory and let it save. And it New Motion, if you click your C drive.
Mine won't let it save at all. It just closes out the program and disappears.
Try it with that administrator mode with the thing. I mean, it's
information.
so here, see the IntelliTech directory? That's where it lives. Here's new motion. Here's user. And then there's my file. So that's actually the file. So if I wanted to submit this for Blackboard for my assignment, right? If I come down here, hello, and I say new motion project and I click it, right? Okay, I can attach a file. So I can browse my computer, and I come to the C drive, and I go to IntelliTech, and I go to new motion, and I go to user. I can find my file bin, and I say open it and submit it. So my assignment is now there. So that'll let me know you turned it in, and I won't lose them in email like I did for some of your drawing files. All right.
Did you lose my? You didn't lose my RoboCell project, did you?
I did not. I did not.
Okay, just making
All
sure.
right. So the well, that's just a way to do it, but shows you that. File saving, like I said, I had my best luck to just let the thing save where it wanted to. I didn't try to rename it. I kept this name. You can rename it once you've saved it. I didn't try to rename it. I left it as that same name because it's a pain, and it seemed to be it would kill new motion every time. I'm going to write a trouble ticket in for that as well. I did support or submit the first one, and I'll write a ticket for this one as well. But for now, that's the only file name I was able to use. You try to change it and it goofs up. And if you try to save it anywhere else, it goofs up. So that's what I ended up with. But that's how you submit an assignment too.
Are you gonna accept the one that I did or no? You want me to do this?
I'll accept it. What you already did, I'll put it there because you sent it to me.
Oh, okay.
Right?
Yep.
So questions on that? Let me make sure that I don't have anybody wanting to be in here again. Participants. Okay, I think Luke's not here yet. And who else is missing? Garrett. Oh, Garrett's here. Garrett's here. And Garrett just never speaks, never shows his face. You know, I can't ever tell if he's really here. All right. So questions on that with the how you do the settings and things like that.
Sounds good.
All right. I want to make sure that you folks had that opportunity to see how it was done. So let me do a new share. Questions? Everybody else making progress? I saw William had done his. He used the 2 push button method, which was different. I expect to see a whole bunch of different things on the way you do it.
Yeah, that was my only question. I didn't know if you wanted to use a push button or that toggle button, that toggle switch.
Push button is what I used.
Okay.
I will.
Me and Jordan got it done too. It's just I cannot save it. That's all.
Oh, sorry.
I got a video of it. I'll send it to you.
All right, that's fine. What? Try and do that save thing. See if you can bring it up and save it. The other thing I found is that you can't save it because the save button is grayed out. Is that it?
No, I can save it. You know, I go to save and like file and everything. As soon as I hit save, and it just disappears.
The program vanishes. Yep. Yeah, you can't give it a different name and you can't give it a different directory. I found that. And other than that, not sure why it wouldn't save. But I know that trying to change the directory or trying to change the thing just makes it.
Yeah, I'll try to. I try to rename it so I can
No.
find it.
No, does not like that. Does
And
not.
you said you got to save it under the administrator one, right?
No, you don't have to.
Oh, all right.
Well, you know what? Let me try.
I thought that's what Bill said or somebody else said when they tried to save it, it just shut down the thing, and probably because we're licenses are expiring or because we're students.
Well, if the license is expiring, but like right now, like here registration, Let me share my
I
screen.
don't
again.
think it
Sorry.
really had to do anything with licensing or anything. I just think it had to do with the adaptability to my computer. It just didn't want to cooperate with the
Yeah.
software.
I think it's a bug or something.
Yeah. Oh, yeah. Oh, definitely. It's buggy. All right. So here you can see I've got my licensing, and I can change the licensing if I wanted. So I'm going to close that. But I'm not running as administrator right now. So let's try this. Let's throw a couple components in. Let's grab my cylinder. I'll do that, and then I'll make the screen big and move this over, and then I'll come here and I'll say C, put a second one in, C, put a third one in, C, put a fourth one in, and then I'll come here and I'll add my air supply, and I'll put it there, all right, and then I'm going to zoom so we can see it. View, zoom in, right there. So there's my zoom. So let's do a file. Save. And then here it's given it the second project. And I found that if I tried to save anything, test save, if I tried to save anything, it failed miserably. So that let me save. I was not an administrator when I did that. And so now I can do a file open, and then there it is, my test save. And there's my 4-cylinder. It's my 4 cylinders.
See, with mine, I don't even get that little window to give me the option to save it anymore.
No?
It did before, it did once. I changed that name and now it's gone. Every time I press save, my whole thing shut off.
Every time you do it now.
Every single time.
Oh man.
I did it like 5 times. Like,
Because you tried to change the name that first time.
I don't know if that's that. I don't know if like it's got a bug. I'm not sure.
You could probably go into that directory maybe and clean out anything that extra that starts with PN. So the directory, as I said, you go to your
I uninstalled the whole thing and installed it again, uninstalled it and installed it
but
again.
it leaves this directory. It
Okay.
leaves this directory right here, IntelliTech,
Okay.
Motion, and the users is left there. So see all these?
I see. Yeah, I can go there, see if it's still there.
If there's any of these PNs, get rid of them and try that.
Okay.
That's all I can suggest. It's a flaky program. I'm sorry about that. So the best I can do. I don't have a way around it. But maybe run it as administrator, Paulo, and
Well,
to do that.
I did run it both ways. That's why I mailed it yesterday. But I mean,
Okay.
I will figure it out. In the end, I can't do it. I'll just take a video of it and I'll send it to you. Hopefully that's all right.
Okay. Excuse me. My morning coffee. And my Claritin.
Naturally.
All right. So let's do a new share here. Jordan went and had his coffee, came back. So how are we doing so far, folks?
Good.
I'll take a video. If you want to do a video, just upload the .movie file, the .mov or the MP4 or whatever it is to your assignment. I'll take that too.
Okay, it's fine. Yeah, I can do that.
I
want to try a few more times and see if I can get it.
It's I'm not particularly happy with the software. I'll communicate that. Right now, I don't want to tick them off because because they are giving us free licenses and stuff like that. So
I see.
One thing I noticed with Hydromotion as I was going through some of the lessons online, they mentioned that the Hydromotion stuff pertains to ideal fluid power systems.
well, yeah,
So it's practically
'Cause
by
it's saying
design
it's not
not
perfect.
meant to simulate an actual thing. So
right.
that's another issue.
Well, you won't
But,
see, by ideal, what they mean is you don't see pressure drops in pipes and hoses. So
Yeah,
no matter how
yeah.
many hoses or connections I do, there are no pressure drops. So
And I wish there was a setting you could change in there so you could.
all right.
As for situations such as these we have right now.
Yep. So I've got here the fluid power hydraulics and pneumatics. Folks, can see the slide. So we're in pneumatics now. We talked about what's our pneumatic fluid?
Air.
Air.
Usually.
Is it plain old air like out of the atmosphere, or do we do some things to it first?
We do some
Compressed air.
Pressurize it.
And clean
We
it.
dry it out and clean it up.
Yep, we clean it, we dry it, and then we use it.
maintain temperature and
Well, then you could
get
also
lubrication.
add moisture to it.
Well, you can add lubricant to it,
Yeah,
generally.
lubricant. Yeah.
Lubricant. I try not to add moisture, but yes, absolutely. And you do condition it. So so we take that air and we get it and we compress it. So this one's about the compressor. So we're going to talk about basic compressors, how they work. And it provides air pressure. Now, how many of you have seen this? How many of you own a little guy like this?
I do.
My father does.
Portable, relatively quiet.
Yeah, I got like a 1970 Coleman.
Relatively
my house.
quiet.
It works
So-
fine. I use it with my
My father's is
finished garden.
bigger.
You can use it for things like this pneumatic nail gun. You would never use this, for example, for spray painting. Just not enough volume. So we'll talk about choice of air compressor. Now these, classification, portable or central, they're identical pretty much in their operation. It's just size and the reservoir. So what are they doing here? They're spray
Pressure
painting.
wash.
Lines.
No,
Are
they're
they
actually
paint
spray
lines?
painting. They've got a paper.
Pressure.
If you zoom in on
They
the
got
book, picture in the
stencils
book,
there.
they've got a paper template or a paper stencil.
Yeah.
And then they're doing it. This guy is doing jackhammering. Okay. So very different style. This guy's compressor is on the back of this truck. Large, high flow capacity. This guy's compression, not so big, but still large flow capacity for the
I don't think that's a jackhammer.
power drill.
Yeah, because he's putting on a bollard setup there.
Could be, could be. Could also be jackhammering out to get a screw out, or I don't know. Hard to say. But the compressors used very, very different. Very, very different.
Did you
And
hear
how do you
about the naval ship that has the coronavirus?
Yeah.
Yeah, I heard about it. The
The
care.
Roosevelt. Yep, Roosevelt. Oh, all right. So the source of energy. So the prime mover, very similar to the prime movers for anything else. Sorry, I muted. There we go. Driven by the prime mover. The receiver is a sealed fixed volume chamber. Two things it does: cools it and let the water settle to the bottom and removes the water, which is why, as we've talked about in the past, there's always a little drain valve on the bottom. Some can be automatic and some can be manual. And it delivers clean, cool, dry air. So here's a basic reciprocating piston compressor. This is not what's in that one with the little tank that your dad uses or you use to compress the air up to 150 pounds. What would you say about this type of compressor?
2 piston, it seems.
Yep. And
Like a combustive motor kind of.
it is. It's an internal combustion motor turned around backwards. Being
It's
driven
also
rather
positive displacement.
positive displacement. Positive displacement. Not a fan, not an impeller, but positive displacement. Each and every stroke of this piston or this piston pushes a fixed volume of air out. A fixed volume of air. Okay? So here we go. The valves can be very simple. They can be literally rubber flappers. They are rubber flappers in that pump you use to pump up your air mattress. Flapper valves, right? As the piston goes down, this one opens. And as the piston goes up, this one opens. This one closes and this one opens.
Isn't that technically what the heart uses?
The what?
The human heart, although that's that's a hydraulic system.
It doesn't use flapper valves because they actually are muscle controlled valves. They're more like irises of the eye. They open and close sideways.
Oh, so there's muscle cells in those things. I thought they were just.
Nope.
The heart is a muscle.
The whole thing. Yep. So.
Well, I know that. I just wasn't sure about the valves specifically.
So in this one.
Aren't they called ventricle valves?
So in this one right here, you can see that we're drawing air in on the downstroke and we're pushing air out on the upstroke. A large number of smaller ones, like the one for your air mattress, every time you stroke this piston down, you're doing stuff down here and you're wasting that stroke. So if I put another valve down here that sucks air in as it goes up and opens up as it goes down, so I put that valve in down here, an identical assembly to this. If I do that, I get what's called a double acting. So every stroke down pumps air out of this chamber and sucks air into this chamber. Every stroke up pumps air out of the upper chamber and sucks air into the lower chamber. So I do it on both directions. That's called double acting. Okay, provides power on both strokes. So here, on this part of the stroke, the pressure in here has not built up enough to close that valve. So it was a fixed volume, but until that valve opens, I'm decreasing the volume. So what happens in here? This valve's not open yet. Piston's going up. What's happening in here?
You'd be increasing
building pressure.
in that chamber.
Pressure's going up, right? And the pressure will go up until the point in which it opens that valve. And that can be set. That can be set. So if you look at it, think about it. If we're pumping out to this tank, and the tank right now is 65 pounds of pressure, there's 65 pounds of pressure holding that shut. So until this inner volume here has shrunk enough to make the pressure in here be 65 pounds, that's not going to open. If it's 90 pounds out here, that volume will get even smaller till the pressure in here reaches 90 pounds. And then at the point in which the pressure in here exceeds the pressure of the system, then the valve will open and the air will flow. Now, and it only moves when the pressure in here is higher than the pressure there. Because for flow and for pneumatic power and for hydraulic power, what do we need for everything? We
Pressurized fluid.
A differential pressure. Yes, we do need pressure.
Oh,
It's gotta
okay,
be-
differential.
It's got to
yeah.
be a differential pressure. There's got to be a pressure difference. If the pressure on this side is 65 pounds and the pressure on this side is 65 pounds, status quo, nothing happens. If this gets to be 70, then I get flow. In fact, if this gets to be 65.27 and this is 65, then if it's enough to overcome the weight of the valve, it'll open the valve. But it
Yeah,
all,
also the pressure differential has to be enough to open that
Yep.
valve.
pressure differential is what it takes to do all of this work. So they're classified using two ways: displacement and how they pump. Positive displacement, we just saw one. Here's one. This is a pistons at basically a 90-degree angle. Why would I do a 90-degree angle, folks? Why do we put on an engine all the cylinders in line? or
Yeah, it's the
offset
same
them?
style as those V-type cylinder engines.
Yep. Why? Why do we
Oh,
make a V?
W, it's the Bugatti Veyron.
Why do we use the V-type engine? Why in the Boxster engine do I oppose the pistons?
Don't know.
Isn't that a different
Or
question?
pressure.
than the
For
Boxster
where?
engine?
For a lower center of gravity, right? Or something.
It's that I'm worried about
It's for
handling,
where?
but vibration and wear. When you talk about these pistons, there's a V8 engine runs very smooth compared to a V6 because the pressures balance in the angle. The pressures balance in the angle. So on that crankshaft, if you think about that crankshaft, at the same moment that on one part I'm pushing the air up, the other part is coming down, right? Being driven by an explosive force. But you do the angles to minimize vibration and to offset the torque and the pressure on the shaft. So in this one, the motor is spinning, right? The motor is spinning the shaft, right? While this one is pushing up, this one is sucking down, and it tends to balance.
And that much does apply with the Boxer engines then.
Yep.
Okay.
Right. So non-positive displacement compressors. Non-positive, what would that be? You got one running in your furnace. You got one running when you put a box fan in the window.
A fan.
Just a fan.
A blower. Nothing, if you can put a piece of paper over the output of a fan and it'll stop it. It'll leak around the outside, it'll blow backwards. You can put a piece of cardboard or you can block a fan. How many of you have ever had your fan tip over and fall face flat onto the floor?
Yep.
Makes noise. Does it burn up? Does it stop? Does it?
No.
No. If you were to block the output of a positive displacement, if you were to block the output of a positive displacement pump, it would break. It would break. All right.
Is that like the fan in your computer?
Yeah. All right. Fundamental
So then
pumping
how
motion.
come you
Fan
can,
is a
how come you
non-positive.
can,
I
Wait,
think.
I'm getting two people at once. What now?
Sorry. The fan is a non-positive displacement pump, though, right?
Correct. You can block the fan and the air will flow back around the vanes. It will not damage it. It'll work harder. You know, your motor will whine and complain. The fan will make a
It'll start
different
to run
noise,
faster.
but it won't destroy the pistons or destroy the pumping, the piping. All right. So fundamental pumping motion. Here's reciprocating pressure. How many pistons can you see?
Two.
I can see two, and it appears
Yeah,
that those two
thinking
do
two.
this. And those
look like the pistons, not necessarily are the
Those-
pistons. But they
are
look
huge. They are huge. if this gives us any scale. And look at, if you zoom in or take a look in your book, you can zoom in. How many belts are connecting that thing to the motor? 5, 6? 1, 2, 3.
I got
Oh, you're talking about multiple belts being used for the same.
Right,
Mm,
right here.
yeah, that way you reduce the load on the belts, I
Now,
guess.
this is probably the intake. Why would you put something like that on the intake?
Well, you mentioned something about removing
Filters the
water.
air, so if like you're in the desert, it doesn't clog all up in there. It actually
Filter, rapidly torches, also muffler. These things, when they're running full speed and they're high volume. I mean, look at the size of the pistons. When that thing is running at full speed, it's sucking a significant amount of air through. So you can actually put a muffler on the air intake to make the noise be tolerable. So you can actually put an air intake muffler, and you'll put baffles in it to separate out any dirt that may be there. So that'd be probably the intake muffler.
A muffler reduces efficiency, though, doesn't it?
Yeah, it does. It does. But sometimes, you need it. Here's a 2-piston, belt-driven, sits on top of a tank. This might be at a gasoline station type size. Okay. Single acting compressors, not double acting, single acting are the simplest. Compress air during one direction of piston travel. Up to 2 to 8 cylinders in line. Here's your double acting. Remember I talked about the double acting? This double acting here uses both parts of the stroke. As it's going down, it comes in this inlet here, and it's flowing out the outlet here. As it's going up, it's flowing in the inlet here and out the outlet here. So it uses both actions. This provides a balance so that you don't get piston knock. Because if you think about it, how would you seal? You have to visualize this moving back and forth. This moving back and forth, because we turn rotary motion into linear motion. Your double acting pump that you use for your air mattress, you have a piston that goes up and down only. That's easy to seal. But if we're using a motor to drive it, this guy wiggles back and forth. At one point, his angle is this way. At another point of the stroke, his angle. How would you seal that? How would you seal that? Like right here. So you put another piston here in the bottom to take that motion. And it doesn't have to be a piston, doesn't have to be seals, can just be a guide to keep that so that this is straight, and you can put a seal here. On some of them, they actually turn this into this will be a metal to metal seal, and then they wouldn't have this piston at all. It would be just connected to the rod the way it is. But double acting. Here's a rotary one. This is a positive displacement.
Vane type, you mean?
Yep. It's exactly the same as a motor, a vane type air motor. You just power it rather than use the power.
You mean like with the Vane type hydraulic ones? That is.
Right.
Motors and pumps.
Well, or a air tool. You have vane operated air tool. Okay. This seal is what makes everything work. This seal is what makes everything work. Seals are generally replaceable. You take off the end cap, you slide them out, you pull them back in. Okay. We have a spring back here to keep it. And which way would this be rotating? Doesn't matter. Depending on where your inlet and outlet are, if it's rotating this way, your outlet would be here and your inlet would be at the top. If it was rotating the other way, this would be the inlet. And in fact, a vane compressor can be a motor, which can be important.
That way it can both add and take away power from the system.
Right.
Or
But
both
the
ways.
other part I want to bring out here is if you do maintenance on them and you have a vane or rotary compressor, you have to be careful with contained energy. If you
Yeah.
release the brakes or if you release the thing and the pressure is sufficient on the downstream side, it will rotate. So if you're there taking a belt off or you're taking something off and there's pressure downstream, it'll be a motor and it will spin. And if there's a wrench on it, it will throw that wrench across the room. And if you're nearby, you know, not anything we need. So it is a motor as well. You have to be aware of that for a vane type compressor.
Oh, okay.
Here's a screw type compressor. Also can be a motor, but not nearly as efficient as the vane type. Because of the way the gears are cut, it doesn't reverse well. But close tolerances, the screw type as the screw, like a water wheel screw. The old style of turning the crank and having to lift the water up, same deal with the air. As this spins, it would be spinning and it would force air through from here, down through, and then out the other side. And this one, not pulsating. Oops. Your vane type, not pulsating. Not pulsating, unlike your pistons.
It might a little bit because of that
The vane,
circular
maybe,
part does kind of.
but it's continuous. And then
Yeah,
this one,
yeah.
this is your turbine. This is your turbocharger. This is your
Also, your
turbocharger.
centrifugal superchargers.
Yep.
The intake half of both of those.
Anybody ever heard of a Roots blower supercharger? It's one on all those top fuel dragsters. That's a screw type compressor. That's this. That's this. Okay. A Roots type blower is this. Right?
That's the non-centrifugal ones, right?
Right. This one is a turbocharger, centrifugal, not positive displacement. Not positive displacement. If something blocks the discharge, it doesn't blow up. There are lots of reasons a turbocharger blows up, but blocking the discharge generally isn't one of them.
Hey, I have a
So-
question.
Yes, sir.
Can you hear me good?
I can.
All right. Can you go back to that previous slide? So near the bottom it says dry or oil flooded. How would it work if all those orifices were filled with oil if there was no like air to be pushed around? You know what I mean?
Oil flooded means there's an oil sump underneath, much like in your
Oh.
piston engine.
It's not completely.
No, it's not submerged.
Oh, okay.
Not submerged.
Maybe you're
It's
referring
like,
to like the bearings or
Yeah.
something like that.
yep, it's like the on your engine, the bottom of your crankshaft, right, dips into the oil pan,
Gotcha.
right?
Okay. I
And
thought
splashes it
all the
around.
cavities were going to be filled with oil or something.
No. And in fact, the close tolerances tend to keep the oil down where it's supposed to be.
Now, in these positive displacement compressors, then, can the oil act as an additional way to ensure that it's airtight? Because I
Yes.
imagine one issue with pneumatics, specifically with positive displacement, is
Seals.
that making things airtight is more difficult than water tightness. So
Yes.
might be a bit more of a
Yep.
tricky.
So
Sorry.
this one is the turbine, high volume, can be high pressure, depending on how much it works. Here's an axial flow. This is a turbine. This is a real turbine. The first stages of a jet engine are this. The first stages of a jet engine compress the air to give enough air so that it can burn at high altitudes. So these are the first stages. This is a compressor.
It doesn't show it very well, but those parts that, yeah, those are actually rotor blades.
They're
those
blades.
spots
Yep,
there.
they're blades. And these are stationary blades.
Yeah, there's a term for that. I forget what it is. They first started using that sort of approach, I think, in the F-106's engine. Or
Well, maybe the terminology, but they've always called them that. This type of compressor, very high volume, and depending on the number of stages, you can get a tremendous pressure increase as well. But again, not positive displacement. Here's lobe type. Lobe type. They use the close tolerance here. As you think about these would spin, this one would spin this way, this one would spin that way. And as it moves through the chamber, these would grab the air and push them through this way. So the air path would actually be this way, or around the outside, depending on how it's set up. Okay?
are those positive displacement?
Yes,
Huh.
yes.
Because they're like those gear ones, but it's kind of only using those 3 teeth for each. Or
Right.
something.
Internal review.
This, there we go. There's a 2 lobe. That's positive displacement, folks. Right? You're all seeing that, right? I hope. That's a 2 lobe. 3 lobe works exactly the same way. This is the volume that's pressurized here. The volume on the outside. 3 lobe, little bit smoother operation, but similar. The machining works the same exact way. Okay, stop.
Are those things going to be a bit more airtight? Because because in the area where there isn't supposed to be any flow, you got a lot more surface contact.
It's all going to depend on the tolerances.
Okay. I mean, for the same tolerances.
Yeah.
I mean, it would have to travel
It has
a lot
to do,
further.
if you think about it, the tolerances are really here, right? You look at it, when these 2 are sealed around the outside edge, when these 2 are sealed,
Okay.
that's where the slippage occurs. That and around the end shaft, around the ends of them. So that's your 3
Yeah,
lobe.
I was thinking of the middle there where they.
Yeah, not much, because it's forcing, this is hitting the low pressure side. Some is going to leak back through. Some small amount of high pressure air is going to come this way, get trapped in there and go through the middle. Right? Again, the tolerances are what's it, all right? So that's the way that type and new share. There we go. That's your lobe type. Compressor staging. Look at the difference. Tell me why.
We got an area difference here.
Yeah, why?
Surface area.
Because
I'd say it's
2
for
different
compression.
pressures for
More
staging.
pressure.
the force required to push this up against the low pressure should be virtually identical to the force required to push this up against the higher pressure, so that the pressure across this guy at each stroke is the same, right? It shouldn't be drastically easier to push this one up or push this one up, or else the compressor, it's going to be a very unbalanced load, right? This part of the cycle would be very, it'd be wato, wato, wato. And sometimes they do that. But what you want is you want the pressure to be equal. As this is moving up, it's doing a large volume, low pressure, but much more surface area. This one is high pressure, low surface area, lower volume, but the force, you can size these two pistons so that the force, when it's compressing, is the same, so that each part of this thing gets an equal load.
But does that mean the pressure is different per stroke?
Oh, yeah.
And that creates a controllable cycle of pressure that could be used for various things.
So this one, there's certainly different pressure. Like this one may only compress to 25 pounds. And this one may take you from 25 to 80 or 100, but it's a much smaller surface area. So I got 100 pounds per square inch here at the end of the stroke. And in this one, I've got 20 pounds per square inch at the end of the stroke. This one's 5 times bigger than that one, right? So the force, the pounds of force is identical on each one. 100 pounds per square inch here, maybe 1 inch. 20 pounds per square inch here on 5 inches. So identical force. Bypass control, we talked about this. Now, bypass control means that your engine runs all bypass control. Engine runs all the time. Start-stop control, used 98% of the time. Start-stop control. You set the pressure regulator, there's a switch that starts it and stops it, okay? And it operates well for systems with intermittent air consumption. If you're running it continuously, because generally this guy is sized to fill it up and then shut off and cool off. Shuts off and cools off. But if you run it continuously, it will build up a great deal of heat. Inlet valve unloading. I think that's in your book. I want to see.
Page 390.
Getting there. I'm at 387, so. All right. So on that one, and I want to go back to the picture because they didn't give me a picture for this one. Come on. So right here. So I've got this compressor here. On suction, it pulls down, this inlet valve opens. The outlet valve is closed. And then on pressure, the inlet valve closes and the outlet valve opens, and it pushes the pressure out. Inlet valve control simply says that when I reach my operating pressure of my piston or my system, a little thing comes down and holds this valve open. So you can imagine it as a little thing that comes down and pushes on that. It pushes it closed, open. So when I reach pressure, it pushes it open. And when it pushes it open, what happens when the piston goes up and down? It just breathes. Right? That's the inlet valve control. When you push that open like that, the inlet valve is opened, and basically, and there is no pressure buildup. It keeps the pressure in here to be atmospheric. There's no heating of the air because it just comes in and out. There's no pressure buildup. It does waste the energy, but not much. Not much, because there's no load really. So it is a no load situation that the amount of amperage going to that motor goes way down. It does make noise. And if you look at that ginormous compressor, this one might use an inlet valve control. Hence the need for the muffler, right? Because it's when it idles, right? Your load goes way down. You don't need to pressurize anymore. Hold the inlet valve open. I mean, realistically, look at this thing. Would you want to do start-stop operation on this? It's massive.
No.
Right? No.
Probably
The
not.
starting current on that motor must be horrific, right? So a big motor, like 6 fan belts to drive these pistons, to get those pistons up to speed, right? So no, you just unload the inlet and it pants, for want of a better word. So you put the muffler there to keep your noise controlled. Okay? That's your inlet type control. Varying compressor speed. This you can do with a vane compressor or a screw compressor. Very, very precise control. Very, very precise control, right? Put a variable speed DC motor like on a screw type or a lobe type compressor or even a vane type. And as you need more air, it speeds up. So that's a very precise control. Compressor inlet size. Varying compressor inlet size. How do you do that? The same way you do some of those variable piston hydraulic pumps. You vary the chamber size. So how do you select it? I'm not going to worry about this much for you guys. How much volume you need? When you go to buy a compressor at Sears or not at Sears anymore, at Lowe's or Home Depot, you're going to pick it for a usage. What do you think your highest usages are? I'll give you clues. Not a nailer. Pneumatic nailer.
Air wrench?
Air wrench is big. Air grinders are huge. Those little air grinders where they're huge loads. Tremendous volume of air going through, right? So those are huge loads. Spray painting. You need a high volume of air to spray paint. So spray painting, jackhammering, something where your airflow is continuous. Let's face it, a pneumatic nailer or something like that is one pop. You're using the differential pressure to slam it. That's low volume, right? High volume is when you have a continuous air to blow out swimming pools, to blow out sprinkler systems. High volume doesn't need to be as high a pressure, but you certainly need a lot of it. Right? Questions? All right. Cooper?
Just flipping pages here.
Oh, you got a sensitive mic because you grabbed the, like, hello. All
I
right.
have one question actually.
Yes, sir.
So I'm gonna send something in the chat here. Let's see.
Can you send something? Oh, there
If
we
you
go.
can click that, I don't know if you'll be able to. click
Hang
it.
on, I can certainly copy and paste it. Okay.
Did it open up? Can you see it?
Well, I'm getting there.
All right, all right.
Okay. You want to show it?
So that was a compressor that we bought last year at Telescope.
All right, let me
And-
share it. There we go. All right.
So that was a compressor that we bought last year at Telescope, and we're like, I don't know if it's hooked up yet. I'm not 100% sure. We have similar ones, like 2 other ones that are just like that.
Yep.
And when they first got it, apparently it had to be like re-geared or something to match the same PSI as the other ones.
Okay.
Or actually, they might have been able to adjust it through that HMI that's on it.
Right.
But I'm just curious as to why they have to match. Like, if it's all just going into a cavity, which is, in this case, like a network of airlines, how come it all has, like, all the input has to match, and how come it's not just like accumulated, if that makes sense?
It's like what Clark said earlier regarding what you always need, but reversed. It's the effect of pressure difference, right, Mr. Clark?
Yep. So let's see. So here I've got compressor A, and here I got compressor B. And I'll put my big, ginormous tank in the middle. This looks like a face now, doesn't it?
Mm-hmm.
All right. I'm glad I didn't draw the circles in a different position. All right. So this compressor comes out here. This compressor comes out here. Let's say this one's operating at 150, right? That's its operating range, and this one's at 100, right? And the demand here, what do I want to control my tank at? 80? Maybe my operating pressure is 80. So I have a valve here that controls my pressure at 80. Just look at this picture. When the set point's reached, which compressor is going to operate virtually 100% of the time?
The 100.
Right, the lower one.
If you're going to run, just like 2 batteries, if you're going to run batteries in parallel, right? Or batteries in series, or no. Yeah, batteries in series, they have to be the same rating. They have to be the same rating. Because what's going to happen is, let's say this guy does kick off, right? And he starts running. Very quickly, he could actually, with the motor, he could actually be forcing air back this way. So you do if you're going to match them, you match them, right?
Again, the pressure difference is going to cause airflow. In this case, unwanted airflow.
Unwanted airflow. Yep.
Yep.
So basically, you match them to provide, so that they both provide. And in fact, depending on the need, you can actually set up the control circuits for these so that for 1 week, this guy's running most of the time. It automatically toggles over for the next week. This guy runs most of the time. If the demand is such that this tank gets below, say, 60, or this pressure gets below, they both start. So you can set up control circuits such that It equalizes run times. And if they're needed, they're both needed, they both run. You can set them all up different kind of ways.
Would the adjusting the cross-sectional area of the new ones feeding and exhaust pipes work?
Different ways to control the capacity. They're all viable ways, but what you want is you want the set point, the pressure set point, to be identical. You could.
I mean, in terms of controlling cross-sectional area.
Yeah, I've seen cases where they'll put a small one and a big one. You want the small one to take care of most of the load, but when you need the big one, you need it badly. So.
I noticed on that HMI that it's might have been that 150 was beyond that particular compressor's
range. Yeah, look like right.
Maybe
this one. That one.
It's not on screen here.
Oh, I'm not sharing it. All right. Well, you want it all, don't you, David? You want me to share and everything?
Well, you learned sharing in kindergarten, so.
Yeah.
Not quite.
Right?
Yeah,
This
see,
looks
the
like
upper
a-
end's only about 110 there.
right.
So 150 may very well be out of what it can handle.
Well, which is why you would re-gear it. Or you would, do whatever.
Yeah.
Right? So.
Here's where you gotta think a bit more like an engineering scientist.
Do we know when we're gonna have our next quiz or test or anything like that?
Next week, I'll let you know.
Well, the new motion was.
I was gonna say your new motion is the quiz. I already said that.
Yeah.
New motion is the quiz. It's due the 24th.
The 24th.
New motion is the quiz.
Okay.
Remember?
Are you getting Alzheimer's?
Only Halfheimers. He's only halfway there. Not Alzheimer's.
Semi-simers. Semi-simers.
Okay, Joseph, do you want me to forward that to Cooper?
No, I just thought I could message him through here, but I couldn't. For some reason, they all go right to you.
You're right. I can allow participants to chat.
Hopefully you didn't say anything appropriate to you.
No, I just let them know somebody's been asking about him every day.
So
Did the message say, Cooper, what's your telephone number?
I can do
with a hug and a kiss.
Participant can chat with no one, so I can set up so you can't chat with anybody.
Right.
Participant can chat with host only. That's what I've got set for.
Are you sure Anthony really wanted to see him, or were you guys communicating through Anthony?
Bill, I'm glad we only got a couple weeks left of you.
All right. So anyway, Cooper.
Just joking. I'll miss you.
Cooper, the message you were going to get was, Anthony misses you. The kids have been messaging me every day asking if you're going to call him.
Oh my God.
I knew it.
I told him that I would relay his number, and he's been asking about that iPod or whatever you have for him every day.
Yeah, I mean, send it to me. I don't know if you can send a chat to me through this or whatever. But.
Oh, let me open it up a little bit.
I mean,
there you go.
You might be opening Pandora's box by giving him your phone number.
I now have enabled chat to go every
He probably thinks you're his best friend.